it's Mrs. Nelson. We're going to be looking in your, or working in your static electricity booklet. So this is electricity unit part A on the bottom of page 5. So yesterday we talked a little bit about that atomic structure that we learned extensively about in chemistry. Today we're going to talk a little bit about early models of electricity. So Plutarch, around 100 AD, believed that the attraction of small bits of straw rubbed with amber was the result of heated air. So that heated air swirled around and pushed the straw to the amber. So here is, and we're going to skip that because we can't have a discussion to talk about that experiment to test Plutarch's model. But amber is kind of fossilized tree sap. So Plutarch charged the amber here, and he saw that the straw bits attracted to it. And he thought that was a result of that heated air. As they charged the amber, it heated the air, and that heated air pushed those straw bits towards the amber. The two-fluid model advanced a little bit of our understanding about static electricity. So each of these pieces are going to have kind of a little bit of an advancement, and then when we put the whole puzzle together, we'll get what we know today. So while the ancient Greeks knew about static electricity, a systematic study was not begun until the 14th and 15th centuries. The existence of two different types of charge had been known for some time when the French physicist Charles Dufay began a series of experiments on electricity in the late 1700s. He discovered that one cork ball touched by an electrified glass rod and a different cork ball touched by an electrified resin rod would attract each other. Dufay decided there must be two kinds of electric fluids. One of the fluids he called vitreous electricity, so vitreous is Latin for glass, and the other he called resinous electricity. Dufay began developing a model for electricity. He believed that both vitreous and resinous electricity were fluids because they seemed to flow under the right conditions from one object to another. An electrically neutral object would have equal amounts of resinous and vitreous fluid. The rod at the left, if I'm just going to scroll down my screen a little bit, the rod at the left has an equal amount of vitreous and resinous fluid. So for this reason, it's called electrically neutral. So here's our picture of our object, okay? And one side is vitreous, the other side is resinous, and it has an equal amount of this fluid. So this he called electrically neutral. An object that was vitreous would have an excess, so that excess is more. So it would have more vitreous fluid, or an excess of vitreous fluid. It would still have some resinous fluid, but not as much. And if the object were touched by another object with a resinous charge, there would be a flow of that electric fluid from one to the other until a balance was reached in both objects. So here are some pictures here. You've got these at the bottom of page 6 in your booklet. So this object here has more resinous fluid than vitreous fluid, so this would be considered a resinous object. The rod at the right has more vitreous fluid than resinous fluid, so it would be called vitreous. And again, if there are two objects had equal amounts of vitreous and resinous fluid, like that diagram in the middle of the page, it would be electrically neutral. But if two objects with equal amounts of extra resinous and extra vitreous fluid came in contact with each other, the fluids would flow from one to the other until they're both electrically neutral. So here is these two objects that have the same amounts of excess of vitreous fluid up here at the top and resinous fluid at the bottom. So the resinous fluid is going to flow from the bottom to the top, and the vitreous fluid is going to flow from the top to the bottom until they're both equal and neutral, like the picture on the right. So the bottom caption says, when the two objects are brought together and touched, the fluids travel from one to the other. The two objects will share that charge equally when they touch. So that was the two-fluid model, kind of sparked by Dufay. The one-fluid model was by Benjamin Franklin in 1752. Franklin began studying electricity. He rejected Dufay's two-fluid model of electrical fluids. He thought there was only one fluid, and its positive or negative nature depended on the excess or deficiency of that fluid. So a neutral object would have the proper amount of electrical fluid. So proper, that's a really scientific term for us. An excess of the fluid would be called positive electricity, and a deficiency of the fluid would be called negative electricity. So that's where we hear those terms. That's the first time those terms are kind of coming to light. So Franklin coined those terms, positive and negative. So Franklin, there we are, was the first person to use the terms positive and negative. So positive and negatively charged objects would attract, according to Franklin, because the positive object had an excess of electrical fluid that can give fluid to the deficient negatively charged object. As the electrical fluid drains from one object to the other, both have the proper, or what he referred to as the natural amounts of fluid, and they become neutral. Franklin also believed that like charges repel because an object with excess electric fluid does not accept any more fluid from another object with excess fluid. Similarly, an object with a deficiency of fluid does not combine with or attract another object having a deficiency of fluid because neither one is able to give that fluid to the other. So the top here is electrically neutral. It's completely filled with electric fluid. This is the object's natural state. The second object has a deficiency of electric fluid. So you see that kind of light blue line where I've kind of highlighted in green. And it's considered to be electrically negative. So the electrical fluid is shown inside as that irregular line. The third object is an excess of that electric fluid and is considered to be electrically positive. The electrical fluid is shown inside the irregular line that is now larger than the object. So that's an electrically positive object. So today we still use those terms, positive and negative, but we have a little bit of a different understanding about the nature of static electricity. But again, we still use that concept of positive and negative electrical charge. So what you're going to do is you're going to go back through those notes and reread them that we just did on pages 5 to kind of 8 here. And you're going to then go and do the questions on the bottom of page 8. So that's task 2, historical perspective questions. So if you're wondering where you get the answers for those, it's from those pages we just filled in. If you've got any questions, feel free to contact me. I hope you have a good day.